Hey everyone, welcome to today's webinar by Viscosity and NYOUG. I'm just going to give folks a minute here to log in and then we'll get started. All right, everyone. Welcome, welcome, welcome. We're glad to have you again for another NYOUG Viscosity webinar. My name is Monica Lee, Marketing Director here at Viscosity North America. If you're not familiar with us, I'll tell you a quick little bit about us before we get started. But first, if you're not familiar with NYOUG, the New York Oracle User Group, they were formed in 1984 for the exchange of ideas, assistance, and support among users of Oracle software products like you. So thank you for joining. You can follow NYOUG at any of these sources online up on the screen. Please check them out. They've always got great webinars like this. They've also got a database of stuff where you can go look at past recordings and past PowerPoint presentations. And then you can also become a member with them and get some additional resources there. So you can find them at nyoug.org. They're also on Facebook, LinkedIn, Meetup, and Twitter. Before I go on a little bit about Viscosity, I want to go over a couple house rules. This is a live webinar, so please take advantage of taking questions if you need. You've got a Q&A section and a chat section. If you've got questions for today's speaker, you can put those in the Q&A and he'll get to them as he can. He'll get to anything else following the webinar if he can't get to them during. If you've got any questions about viscosity, about if you're having issues throughout the presentation, you can send those to me through the chat section and I'll get to you and help you out as I can. So with that, a little bit about Viscosity North America before we get started. Viscosity was formed by former Oracle employees. Hopefully you recognize a couple of them on a screen later, but we are based on 3 different pillars here. You can see data, apps, and cloud. We've definitely been helping most of our customers over the last couple of years migrate and upgrade to 19C. And we, as you can see on the left side of the screen, these are some of the things that we provide across the 3 tiers. Things like health assessments, migrations, tuning, custom application development, training, you name it, zero downtime migrations. These are a lot of things Viscosity is known for, and we are definitely happy to help you with any of your Oracle needs, full stack. One thing people like to come to us for is assistance with license management and being that middle ground between Oracle and your organization for purchasing any hardware or software. These folks that you see here, hopefully you've seen some webinars, in-person sessions, read their books. These are some of Viscosity's management folks that have been a big part of the Oracle community. They're part of the Oracle ACE program. If you're not familiar with that, Oracle recognizes folks in the ACE program as people who are going out of their way to, continue the research, continue discussing all of these new technologies with Oracle users around the world. So we're very proud to have these folks on our team working for our customers, and of course, being involved in regional user groups like NYOUG and some of the national ones as well. So these guys have been writing, they've been presenting for a long time, and they are definitely worth reaching out to if you need anything. Pretty much all of them are responsive on Twitter alone, and if you need anything else, you can let me know. All right. This screen pretty much shows a couple more in detail things that we provide as well. I'm just going to keep going here. These books, I think we're going on like 21 books between our teammates, but this is just a little sample, and hopefully you own some of these. I think I need to update this page a little bit, but these are great industry standard books. Between Charles and Rich alone, we've got a ton of books. All right. And then as of the first of this year, Orapub.com is now powered by Viscosity. If you're not familiar with Orapub, it was founded and run by Oracle ACE director Craig Shallihammer, who was originally part of Oracle Corporation as well. He started this long ago as a place to just house Oracle-based training. And now this is where we house all of our webinars that are free. And then we also offer some live training, multi-day training that you can pay for through here as well. There are a couple tiers of memberships you can get, but the free membership allows you access to webinars like this today, many, many more, and the slide decks that go with it. So definitely check it out. That's www.orapub.com. And then last slide before I introduce our speaker and he gets his deck up, you can check out our calendar at events.viscosityna.com. It's going to show you all the things coming up. Next week, we're live on location in Salt Lake City if you're out there. Oracle Cloud World is coming up here in October. We'll be there as well. So things like that, you can always look for us. Sometimes we've got lunch and learns, happy hours, mixers, things like that. So if we come to a city near you, I hope you can come say hi. And if not, we are always online with NYOUG and our consultants. All right. So with that, I'm going to stop sharing my screen here. And introduce you to Peter. Peter, if you want to go ahead and get your slides up, sorry, give me one moment. I think I need to make you a co-host. And for those of you who are just joining us, yes, it's a live webinar. Yes, it is being recorded, and yes, you'll get access to slide decks afterwards. So just hold tight. You'll get a message from our team when everything's ready for you to view. All right. So Peter Koletzke is our presenter today. He's an Oracle ACE director, and he's worked for over 38 years in the IT industry. And he's presented at various Oracle technology conferences around the world nearly 390 times. And additionally, he's won over a dozen user group awards from NYOUG, UTUG, that's Utah Oracle User Group, ODTUG, Oracle Developer Tools User Group, and ECO, and SEOUC, which I'm not familiar with that one. ECO is East Coast Oracle User Group. And Peter is also an Oracle Certified Master, UTUG board member, and a past board member of IOUG and NYOUG. And he's co-authored 8 books with familiar names such as Duncan Mills, Avram Roy Fetterman, and Dr. Paul Dorsey, published by Oracle Press. The things he writes about include Oracle JDeveloper and ADF, Oracle Forms and Reports, and Oracle Designer. So thank you so much. Hopefully I said all those things right.
yeah, perfect. Yeah.
Thank you so much for presenting for us today.
Yeah, it's a mouthful. Yeah, I wouldn't want to claim Oracle Designer so much anymore. That's a skill from 20 years ago, but we did write the books on it anyway with Dr. Paul Dorsey. Yeah, so I put this session together because I thought when I was learning PL SQL originally, version 6 of the database, which actually wasn't PL SQL in the database, it was PL SQL in SQL Forms 3.0. I was thinking, how do I learn this language best? And wouldn't it be nice if somebody had some tips that I could look at that would make my code run faster. So obviously at that point there wasn't such a thing because the language wasn't as developed. But as we went along and the PL/SQL evolved, it became evident that there were certain things that you could do that would make the code run faster and better. And so there's been these kind of best practices slash good tips and techniques to know developed along the way. And I did some research and put all of this kind of into one session. So I thought it'd be good for review for those who have been working with PL/SQL. I know some of you have. I've recognized some names out there for a while. And those who are new to PL/SQL, it might be useful to know, what you want to use as guidelines for developing your code. Oh, by the way, the little thing at the bottom left corner, Oracle ACE X question mark, is because the Oracle ACE program is going through an evaluation process at the moment for 2022. So my ACE director title is kind of not there yet, and we'll call it that. So as far as me, this is my, I guess, shortcut CV, which Monica's kind of covered already, so I don't need to go through this very much. So when you have performance issues, this is what developers think the problem is probably due to. 80% of the problems are because of the RDBMS, the database itself. Network maybe 9%, internet maybe 9%. And development code, of course, it has no flaw in it, so there's no problem with the performance. So we want to focus on the database part. We blame the DBAs, right? So that's, as a developer, that's what I do. On the DBA side, of course, it's completely reversed. 80% of the time they think, well, no, it's going to be development code. It's not the database. Database may be 2%. Internet and network, yeah, we'll agree with the developers. It's probably about 9% each. It could be the problem due to network or internet, but mainly it's development code. So the reality is that it is probably because of application. There may be a problem with some of the code. There may be, some inefficiencies in what's being done in the application code. The database is tuning itself these days, quote unquote, and PL/SQL itself is not causing a delay, the processing, the compilation. It's pretty efficient, 30 plus years old. So it's either, developers say user misuse or the network, Windows upgrade, caused a problem. The Herman, who's the retired developer, of course, caused all this problem. So we're going to blame it on Herman, and or phases of the moon, Mercury in retrograde. There's all sorts of excuses that we come up with, but bottom line is it's probably some problem with the way that we've developed our PL/SQL code. Yeah, so here's a good one from Dan Solomon. Sometimes it pays to stay in bed on Monday rather than spending the rest of the week debugging Monday's code. So this week we're ahead of the game. We're on Tuesday already, so we don't have to worry about Monday. So I've kind of grouped the tips into these 5, and then I say plus because there's lots more. These are really the ones that I feel most people are concentrating on, and the ones that I've used before that are best for code. Oh, and then just a note on the right, the recording will be at NYOUG.org, and also, as Monica mentioned, it'll be available at Viscosity, and Orapub rather. So the top tips I came up with, and again, these are kind of groupings. One is tune the SQL using packages, tuning the loops, caching the code and results, and using data types correctly. And then there's a whole bunch of other stuff. So this is about kind of sales pitch about efficient SQL. So 60% of PL/SQL is SQL. PL, procedure language SQL is what the name of the language is. So we have to kind of worry about the SQL first. So these are things you say, oh yeah, done that, been there, done that. Just reviewing again for those who are new, and maybe just as a reminder for those who are not, who've been out there for a while. Indexes are very important, but full table scans are not bad for small tables. You don't necessarily need to use an index if you have a small table. but you have to examine costs as well as timings. How much CPU usage are you getting? And index-only tables are a possibility. Turning indexes off for bulk loads, dropping and recreating them so you don't have the overhead of the indexes being loaded as you're doing inserts. 19C has automatic, and plus has automatic indexing. And remember that the index won't be used if a function is applied to the column. So for example, upper department name, that department name index won't be used, but you can have a function-based index where you can define the indexes that function upper, and then that index will be used. The function-based index will be used. Don't trust the optimizer. You want to run explain plan to be sure that you've got your SQL running most efficiently. And this is, I'm talking about SQL that's embedded in PL SQL. That's why we're doing this. Obviously, if you're just doing SQL outside of PL SQL, these tips are valid as well. But when you're doing it within PL SQL, it's the same problem. You have to tune your SQL. Analyze tables, that gives the optimizer the data it needs to figure out what the optimization should consist of. And then trusting the optimizer is the other side of the coin. You don't want to use hints unless you really, really need to, because if data volume changes or something else, or there's a database upgrade and there's something different about the optimizer, then your hint may not be valid anymore, or may actually slow things down. So you have to kind of keep watching that if you're using hints. Oh, also insert, update, delete, use query syntax. So you have where clauses in those, and you have to be sure that those are tuned as well. Tuning your queries. So views obviously are select statements. So you have to be sure that the queries to views are optimized for the select statement that the view consists of. Using a tool to get hint suggestions, if for some reason you do have to rely on hints, is a good thing. So you don't have to kind of know all of the ins and outs of all the different hints. These tools will let you run multiple versions and different hints and give you the optimization, or the best optimization. Another option for queries is that you can break up large union or other complex statements into multiple statements. Sometimes it's actually more efficient rather than having some kind of a single, monolithic query, to break that up and actually do the individual pieces of that, collect the data into a table. You can use a global temporary table, which is basically a memory area that you can load that will be retained in memory during the session until you do a commit. And then you can query that in the same session, and then that goes away after that session dies. So it's a kind of a scratch pad area. You throw data into it, and then you can query it, and then you're done with it. So you're not maintaining storage for that data. So it's never a problem with concurrency, but yet you can load it and then query it and then use it, and then it goes away. And there's variations on global temporary tables. So something to look up if you haven't had experience with that. I've used it pretty successfully for breaking up very large union statements. And using materialized views. And I don't know if the animation showed that materialization, but there is a materialization of that beautiful view on the right side. We all wish we were in Hawaii. Some of you may be in Hawaii, who knows? It used to be called snapshots, but it's basically data that's stored. So this is not like a global temporary table where data goes away after the session dies. This is basically another place that data is stored based on a select statement. And then you can decide when you want to refresh it. It could be on commit, which means every time you make a change to a table that's underlying that query, then the materialized view will reload or will load the new data. You can do a fast refresh, which is on a commit. And you can also do the enable query rewrite clause, which basically gives you the ability to, when there's a query done to a base table, if that query could be using the materialized view instead, it will query the materialized view, even though your query is written to the table. So that's a pretty powerful way to get use of the materialized view. So it's basically when you have a very complex statement that you need to make faster by loading data into an actual table. And the actual table is associated with a select statement. So high frequency queries, complex queries, those kind of things. If you have embedded PL/SQL within SQL, for example, this my function XY from table, it's actually better not to have that embedded function. And there is a way to make that better, which this is really before 19.7, version 19.7. You can see details about this on this YouTube video about calling PL/SQL functions from within SQL, but it's better to do the processing of your PL/SQL side outside of the query so that your PL/SQL isn't embedded inside. You can do query PL/SQL tables with the table cast clause. Yeah, so that's basically, yeah. So SQL macros, and this is the new thing with 19C and beyond. Well, 19C, not 20, but 21.3 plus. You embed the PL/SQL function inside SQL without context switching, and you use this SQL macro syntax, which basically gives you the ability to put the code that's within that PL/SQL within the query, and it embeds it automatically using that SQL macro syntax. And there's not enough time to explain this fully, but it's basically something you want to look at. And here's the Tim Hall's, I call it legendary Oracle base. If you don't know the oraclebase.com website, you've got to check it out. It's got everything about all versions of Oracle and very much detailed real world examples and great stuff. And he keeps it updated based on all the new versions. So this is the page that you would go to look at SQL macros. And then 21C docs will have it as well. Okay, we're going to skip the table cast questions. There's some slides in here you may want to look at later. As Monica said, they'll be available. Slides will be available. Maybe she didn't, but they will be on OraPub, and some other SQL tips. But we're going to skip that for now and jump to, I think you got the idea. Tuning the SQL is important, right? Use packages is the next one. And you ask, why do we need to use packages? And the main reason for performance is that the package is loaded into memory on the first use. So anytime any procedure, function, or variable is used in that package afterwards in that same session, the database doesn't have to go back and reload the code. It's already in memory. And hides implementation details. These are more security-oriented things. So you grant to the package and you don't expose the package body logic to the user. They only see the specification part, which is the calling syntax. And you can use session variables that are kind of global, declaring those in the package specification, then they're available everywhere in that session. So it's kind of a controlled way that you can create memory areas within the package, so that you can use data back and forth in that same package within the session. And it also, this is just an organizational thing. Instead of having 500 functions and procedures, you have maybe 10 or 50 packages that group those functions into logical groups, just for an organizational standpoint. And it makes the grant more easy. It makes the grants more easy to create because there's fewer of them. So you're doing it on the package level, not the function level or procedure level. Also, you can implement this idea of a table API, which is worth spending a couple slides on. I've got a whole session that I give on table APIs, but we'll bore you, or we'll fascinate you with a couple of details about a table API. If you're not using a table API, many of you may be using a table API. It's basically a PL/SQL package per table or business entity. It doesn't have to be just a table. Table API is kind of a general term. And you have procedures for all your DML, insert, update, delete, and lock, either single row or multiple row or both within that package. There's procedures for each of those. And I've got some samples at that link. Oh, I put the link twice in the slide. And then those procedures call business rule validation code. So you basically do all your SQL in in procedures, and you don't actually allow the user to issue SQL directly to the tables. So that gives you control over what data they put in, and you can validate the data before it actually goes into the database. Update, insert, delete, any of those things can have business rule logic around them. So procedures from application, yeah, so you can call procedures from the application code, or you can call it from view trigger code. Okay, there was a question. Suzanne said packages versus procedure. I need a little more detail, but I'll keep going, and Suzanne, you can supply some more detail on what you mean there. Table API benefits means you've got logic on the database side, which this is what this is all about. PL SQL is database side. And that's big benefit for using PL SQL is that you've got code in the database, looking at the database, and there's no messaging back and forth. It's all there in the same place. Simplifying the user interface code, so you don't have to write lots and lots of logic for business rule validation. You do all that in the application itself. You do that in your backend database code. And then I said promotes good security practices if you do it the right way. So accessing packages only, not tables. So the tables are protected by the grants, or no grants rather, and the packages are the access to the tables. Logic is hidden, so you're just looking at the package specification. This is an example table API for this jobs table, which is one of the standard sample tables. So there's a column, a parameter for each of the columns in the table, insert and update. And these are very simple examples, and you'd have update, you'd have delete and lock as well. And then the body does something like this. And then, at the beginning of the procedure, you would validate the data before you do the insert. And if the data is not valid, you issue some exception or something going back to the user that says, you can't do that, and then you would not do the insert. Otherwise, you do the insert. Okay, so, package use of memory loading versus a procedure and perhaps functions within a procedure. Subfunctions within a procedure, right? Yeah, so I mean, subfunctions within a procedure are more like a package. So the main thing is that with procedures, you usually have more procedures than you would packages. So you're handling, if you use packages, you're handling things on a more global basis. You're doing, groups of functions and procedures rather than individual procedures and functions. And then, again, loading the full package in means that you have access to all the procedures and functions within that package in the session without having to have the database look it up again. I hope that answers the question. Okay, so that's the sales pitch for using packages. Tuning loops is also important, because if you think about this, when you're processing data, you can be doing, 100 rows, you can do, millions of rows, you can do billions of rows. And as you do more and more of one single operation, the delay for a single operation adds up significantly when you get to those larger numbers. Normal PL SQL is pretty well optimized, so you don't really have to worry about the PL SQL part. But if you have things inside of loops, they can degrade performance significantly. So here's an example of a nested loop where you've got a query on a department ID and then a subquery, basically a sub loop. So you have a loop on the department table selecting department ID, and then you've got a loop inside that which uses that department ID as a filter for the query for employees. So you're doing outer loop, inner loop, and you say, well, duh, nobody would do that, because what you would do is instead combine the two queries into a single query and just do a single loop, which means you have fewer context switches back and forth between PL SQL and the cursor opening and closing, or the cursor fetching and closing and opening and whatever the cursor is doing. But this may not be as obvious as this particular example. So it's something to look at. If you've got nested loops, can you combine them? All right, so that's the main point there. Using bulk collect, which is one of those things that if you're not doing it and you're doing processing of multiple rows, then it's something that you need to learn about. It's considered, I think, the most significant performance benefit that you could do to change your code, because you're basically dealing with arrays, more than one row, as opposed to individual row processing. So it's another way to avoid loops, because it's a way to avoid multiple iterations of a loop. There's still loops involved. So here's an example. It's a cursor on a transaction table that's selecting some columns from the transaction table. And then we create a type that is that row type for that cursor. And then we create a variable that is that table type. So we have the cursor that's looping through the records, and we're loading it into this table of records, basically, in PL SQL. So we open the cursor, and then we start the loop, and we do individual fetches, but we use this phrase bulk collect, which means that we're collecting more than one record. Normally, when you do a fetch, you fetch one record. But if you do bulk collect, you fetch as many records as you want. You can have a limit based on what memory is needed, or what memory is available. It may be that it's not a very big set of results, and you can load it all without a limit, but you have to kind of deal with what your memory available is for that. So in this case, we're fetching 500 rows, and then we do some processing. With this comment here, we'd be doing this insert records thing. We'd probably be doing some processing on those records before we do an insert back into a summary table. And then this would be the example of how we load that full array of 500 records back into this other table, transaction summary table. And this is a full single statement to the database. So for all is another way to handle the array processing. So the first part is bulk collect, which does the select, and then the for all will do the insert or update. You can do updates or deletes, any kind of operation like that. And again, it's done on an array of records, which makes it enormously faster. And then we exit when there's no more, when there's nothing left in the cursor. And then we close the cursor, standard stuff. So it's standard cursor stuff, but the main point is the bulk collect and the for all, because you're handling the multiple rows. Caching the code and results. So this one idea is to load, if you have multiple places where you're looking up data in some fairly static table, you can load the table into an associative array in PL SQL and then query that array. And I've got a link down here for Don Burleson's article on PL SQL object types, which talks about associative arrays a little bit more. But basically, an associative array is an array where you're dealing with an index that is that can be a character index as opposed to a numeric index. And I'll show you an example. That'll make sense if you haven't dealt with associative arrays. So you load the PL SQL table, package table variable with the data, and it could be the whole table. It could be whatever data you think you'll need. And then when you need to query a particular lookup value, then you query that data in that array, in that table, PL SQL table, as opposed to the actual database table. And then you're dealing again with memory area and not with queries that require, the database CPU usage. Or you can use an application context. Application context is another memory area that's set up for a session that you can load data into. It's more limited, but it does allow you to load some data. Okay, so here's an example of the associative array. The package is just I call it cache test. And I set up a table of varchar 250s with an index of varchar 225. So the idea is that I want to load my employee name and names into a table that is indexed by their email address. So when we issue the email address in a function, we can say, we basically say this employee's name is, and then emp, which is the variable with email as the parameter, and that'll be the index to that row in the varchar2 table. And then the body is nothing, but I have an initial, this X is here because you need something in the body. You would probably have other procedures and functions, but in the initialization section in the body, which is executed the first time you access the package, I just have the DBMS output to show that we're actually in that initialization, which you'd comment out later. And then I've got a loop that loads the data from the employees table into the emp table of records variable. And it does it with the index of the email address. And it loads the name, which is the concatenated first and last, if that makes sense. I think I've got a demo. Yes, I do. All right, so we're going to jump over to SQL Developer. And let's see, is that going to appear? Is that going to appear in? No. Let's try that again. I'm trying to find my Zoom session to be sure that you can see that. I'm going to assume I can see it, that you can see it. And if you can't, please put something in the Q&A. All right, so I've got PL SQL, well, yeah, so I've got that package created in my HR schema here. And I have a little tester here, which basically is showing the email addresses in this table is just the name. It's not, it doesn't have to anything with a domain name in it. So I guess because they assume the domain name is the company name. So, the email address is basically, for this one is sking, and then we're going to look at the emp variable, which is loaded initially when you access the package in the cache test package, and then pass it the string, which is the email address, and then we should be getting the name. So we're going to run this. I think I'm connected. I think I haven't timed out. We'll find out if the demo gods are okay. Yes, they are very kind today. So if you remember, there was a DBMS output in the beginning of that initialization section that just shows this message. And then this is what happens for each of the lines of that tester. Then if we go to another, I'm going to clear this output. So a different set of data, right? These are different employees, and we run that one against the same package. And I'm in the same, I'm not in the same session. Okay. All right, so now I'm in the same session, and you don't see that initialization message. You just see the data, right? So it didn't run that again, which means that this is the proof that shows that we are only querying the table, the PL SQL table. We're not querying the database table. The database table is only queried, if you remember, during the initialization section. So, and that's only done once. So this is a way that you can actually save some time by loading stuff into memory. Okay, this is what we just looked at. So this is the slide version of that. Function result cache, do we have time for that? Yeah, let's just do a quick one here. So 11G plus, you can use the PL SQL function result cache, which is similar. It basically, but it's something that you don't have to code at all. You just put that that syntax in when you're creating the function result cache, and then it will basically return the same value without querying the database if that value has been queried before. Another option is to pin packages in the shared pool. If you have to do those, if there's packages that are always run, it may be faster to load those, when the session starts up, and then they'll be available rather than loading it the first time they're used. Okay, using data types correctly. Oh, yeah, so if you need an integer, and this is actually another powerful one, using PLS integer, simple integer, is much faster than using number or integer. And this is an example. I ran, there's this sample code, which I'll show you in SQL Developer because I have it here. And this sample code has kind of proliferated, and I couldn't find who actually wrote this. It may be Oracle, I don't know, but Tim Hall has it, Don Burleson has it. And basically we're setting up different, two different variables for each type of number data type. So integer, number integer, PLS integer, binary integer, simple integer, and number, this number of loops. And we're running this 100 million times, but it's very simple. It's just adding number 1 to number 2 in each case, and then showing how long it took. So you do the get time for the start, and then you subtract that from the time that it is after the loop ends, and then you display that. So and then it does that for each of the types. So it's very simple, but I didn't have to write it. So we'll clear this and I'll run this. It takes maybe 10 seconds because it's a million, it's 100. I have to reconnect again. Oh, right, because I haven't connected that one. 100 million rows, it takes like, I don't know, 10 seconds or something. But this is just a demonstration of how it's more efficient to use these specific data types. And the best of all of these is the simple integer. The drawback is that it has to be a value that's not null. So simple integer, well, in this case, 175 is a little bit less, a little bit more than the binary integer, but they're still considering simple integer better in both compiled and interpreted mode. But you can see the difference between number, number and integer. If you're just using integer, and if you need nulls, you have to use something that will accept the nulls, like a PLS integer or an integer or a number. But the difference between simple integer, binary integer, and PLS integer, well, are not that much, but between that and integer is quite a difference in number as well. And this is very, 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 very simple example, simple adding 1 + 1 kind of thing, but you could have more complex things that would slow this down, and you might even have more than 100 million rows. So, and these numbers are, at one point in time, that's what I got, but the idea is that the simple integer is usually better. So, if you can deal with the not null, if you try to put a null into a simple integer, you'll get an error. So you have to be sure that your examples are actual numbers. Oh, and I did find documentation that says PLS integer and binary integer are considered identical if you're in 10G or beyond, but yet I keep getting different numbers for those. So I'm not sure, is that caching? What is that? What is happening there? But in any case, that's they're still better than using integer or number. And then if you need a floating point, use binary float or binary double, depending on what size number you need. Same idea. Okay, so I'm getting a question. Shouldn't the loop and cache test have had imp c? Okay, let's go back quickly to cache test question about the loop cmp name, e name. Yeah, e name. Okay. Oh, the question, I don't know if you can all see the question, but the question was, should the loop have been at the in this line? Should not have been amp e name equals c name. But what we're loading into this varchar2 is the actual name, first and last name, with the index of the email. So when you assign a variable, array variable, you have the index in parentheses like this. And in this case, the index is the varchar2, which is the email. So when we're doing the test, we're sending the email name, the email. This is an email, by the way. I know it doesn't look like an email, but the email is sking, and we're sending that to, or we're using that as the index to get to a row in that table. And in that table is, PL SQL table is the actual name, first name, last name. So hopefully that explains that. I can send you that little tester if you want. Oh, yeah. Okay. So this avoiding implicit data types conversions is another data type thing. You can easily do both of these. So you can say I equals 1 in quotes, and PL/SQL will say, oh, let's see, is I as the PS integer, is that really, but within quotes, is that really an integer? And it'll convert it if it is an integer, and if it isn't, then you get a data type error. And same thing for date. If you have a date data type and you load a string into it like that, if the NLS date format is that string, then you're fine. And if it isn't, then the database won't know what to do with it. But again, it's translating from the string to a data type. So there's a little bit of processing involved. But if you send it the actual correct data type, so if you would do a toDate here on the date string, and you do a toNumber on this side for the number sign, if you need to put it in quotes. So best to not have to make the database do its conversion in the PL/SQL conversion. No, we're gonna, oh yeah. No, let's skip this one. All right, you can look at that later, but there's a strange thing. Okay, so plus. So we have a couple of minutes left for some plus tips. We're not going to skip. Yeah, so let's do all these here. So profiling, when you're doing, so the 5 categories that I just showed you, I think are the most important, but these are also things that a lot of people have mentioned and things that I've been using as well. When you're trying to figure out performance and you have some slow running process, you want to figure out where the slowdown is. And profiling, which is analyzing the code, is a way to do it. The simple way to do it is the get time, which we had in that example for the number data types. And what it does is it gives you the time in hundredths of a second. So you have to divide it by 100 if you want to look at seconds. That's kind of it's a lot of code, and it's stuff that you'd have to embed extra lines of code in your procedures and functions to be sure that you're seeing the right thing. Better is to use a profiling package, hprof, or a DBMS profiler, which is the older version. The newer version, hprof, is actually more, it's considered better and more functional. It lets you get deeper down into what exact section or line of code is causing the problem. Another simple thing is if you just have kind of one-off things, you can embed the DBMS application info package calls to inject values into the session, and then you query the $session view to look at the action and client info columns, and then that'll show you data that you've been entering. So you could put in at this point in time, this variable is this, and then later on you can see a different value, and then you'll see that in the $session. But it's a dynamic thing, so it's not like you're looking at a log. You may have to actually do logging as well, but the profiling packages are actually a better way. Okay, these are just kind of quick things. Using select into, in the old days, we kind of avoided select into rather than open fetch and close, just because it was considered more efficient. But these days it doesn't matter. Avoiding excessive context switches. So if you're embedding PL/SQL inside SQL, we talked about that a little bit before. Using bulk collect, obviously I've hammered on that one. Implicit is faster than explicit. So just doing a select rather than an open loop fetch and close is faster. Variable declarations inside loops. So you can actually declare, if you declare a variable inside a loop, then it's a little bit slower than actually declaring it outside because you're doing it multiple times, which I guess would make sense. You can have a declare section inside a loop and then declare that same variable multiple times, but that's obviously going to be slower than doing it outside the loop. Again, there's a link to get more detail about that. Subprogram inlining. So if you're calling a procedure or a function in a loop, that overhead can add up. So you can actually use this pragma statement with the procedure name, which embeds the code inside the loop, which means that you're not calling the function or procedure. That code is compiled into the loop. You don't see it in your code, body itself, but when it's compiled, it'll go inside the loop, which means that it doesn't have to have a separate call outside the loop. And there's some, there's a parameter, database parameter that has to be set, and there's some limitations. So you want to read the docs on that. But it's an 11G and beyond feature. Conditional compilation. This was available in 10GR2, so we've had this for a while. You put the $sign in front of your if then else statements, and then the compiler will actually look at the value of a variable. So if you set up a debug package.doDebug as a Boolean, and you set it as a constant Boolean, and then when you compile that package, if it's set to false in your package spec, then all the lines that start with the $sign will be commented out, will be removed. Actually, you won't even have those in your compiled code. And then if you want to set debugging on, then you turn that variable to true in your doDebug package, or whatever you call it. And then when the compiler compiles the code, that code will be active. So you'll be able to see those debug statements, DBMS debug statements. Conditional compilation is the name. Any other questions here? Okay, I don't see any other questions yet. All right, so bonus tips. Start with use. Okay, yeah. Bind variables when you're doing dynamic SQL. This is one of the key things everybody says because it's true. Using bind variables means that you're going to have less processing for the actual query. The query will be loaded, the path will be set, and you won't have to have the database figure it out again. So the parsing will be there. This is a good one. Paying attention to the order of conditions. If you have if then else statements with multiple Boolean outputs, so an if clause always has Boolean true or false at the end of it, as its evaluation, depending on, so it determines where things go. Same thing for case and when. So if you have, for example, a statement that will evaluate to false and another statement that will evaluate to true, and you have an and statement, then the database will look at the first one and it'll say, since that's false, and means both have to be true, so we know the whole thing is false. We don't even have to look at the second statement. So where I say false and true here are actually would be expressions like x equals y, or I equals 10, something like that. So whatever you're evaluating evaluates to false. If you put that first in the and, then it's more efficient because the database can fail right away instead of looking at both statements. If the one that usually evaluates to false is second, then it would look at the first one, see true most of the time, and it'll have to go to the next one. So it would actually be doing two evaluations. Yeah, so if false is first, if the thing that's usually false is first, right, then it won't even go to that second one. Regex is actually better than handcrafted parsing stuff. So if you've created all this marvelous code that parses a string up and divides it up and mangles it and mashes it and manipulates it, it's possible that you can get a regex expression to do the same thing, and it'll be much more efficient. It's a bit to learn, but there's lots of examples out there, so it's worth the time to check it out. And you can always fire off long-running processes if there's something in the middle of your code that takes a long time, but the output for it doesn't determine what happens later. Then you can fire off a separate session, an asynchronous session, and it could be DBMS job, could be DBMS AQ ADM, and then that process can continue without you slowing down the rest of everything else. So basically, you're spawning a new thread, within your code that will do something and then create the output that you want without slowing everything else down. Follow-up reading. Lots of stuff to read. Believe it or not, the Oracle docs are a great place to start. They actually have a chapter called Sql Optimization and Tuning. Amazing, huh? So they've actually collected all the stuff that we figured out over the years and put the top stuff in. And a lot of the stuff I've talked about actually is here. I think this is a 19, is it? I think this is a 19C one, but so you can look up Oracle Database PL/SQL reference and then whatever version you're using, and you'll get a link like the one at the bottom, and you can just explore stuff and look for that optimization and tuning one. So obviously you get the whole language reference here, but there is this optimization and tuning chapter. Not backwards, forwards. We're going forwards. There we go. So, and then there's, Michael Rosenblum and Paul Dorsey, Dr. Paul Dorsey, President Emeritus of New York Oracle User Group, wrote this book about performance tuning in PL/SQL. It's a whole book. And they go into HProf, the hierarchical profiler in great detail here. And this is a great book for just learning about tuning. And you'll see a lot of the things that I've talked about here already. And then Rich Nemec, now famous viscosity North America guy and Oracle Ace, and overall great guy, writes all these books, tons of books. And this was a 12C book, but he's updated this now, I think. And it's database performance in general, but there's a lot about PL/SQL in here. So highly recommended reading for that one. Quiz. Yeah, let's do the quiz. The quiz would be fun. Oh, some other books. Yeah. Tim Hall's book, I put a star on. These are all other PL/SQL performance tuning books that I found. But Tim Hall's book, I put a star on, and he's got some sample chapters out there even you can look at. I'm not getting any commissions from these guys. They don't make any money on these books anyway. They spend years on them and, get like, I don't know, $10 royalties. I can speak from experience on that. Sometimes negative royalties. My royalty statements are sometimes negative because people return their books and then the publisher dings us for that. Question, is there recommended reading on Regex? Wow. I don't have anything specific, but there's lots out there. I don't have any favorites on that one. Well, I do, but it's a book by Alice Richard, which has a chapter on Regex. It's a SQL language book, but I would just look out there there's just tons of information. Sorry. There's white papers and conference presentations out there as well. And more about the profiler at that website. PL/SQL office hours. This is an interesting one. If you haven't looked at or you haven't been out to the office hours, they have them on multiple subjects, but there was one for PL/SQL, which I think is kind of inactive now, but they do have lots and lots of videos. I love this one on modularization controversies from August of 2019. So they discussed functions versus procedures for 21 minutes. I was there. I watched them live do that. And yeah, the video's out there. Great stuff. Okay, we're going to skip the quiz. You can look at the quiz later. It's kind of silly. So summary is, tune the SQL. That's 60% of PL/SQL is SQL. So the embedded SQL that you've got there is a great place to put SQL, but you got to be sure that that SQL is working right. You can't just embed, non-running, non-great SQL inside your PL/SQL. It's got to be great SQL. Using packages saves on memory loading back and forth. Tuning the loops, try to reduce the number of times you're looping, and also use array processing with bulk collect. Caching the code and results. If you've got tables that you query a lot, you could load into associative arrays or figure out some other way to load memory rather than querying the tables repeatedly during a session. Using data types correctly. Try to avoid integer if you can use simple integer or PLS integer, for example, or if you need floating points, use the PLS double. And then keep reading. Lots of stuff out there for reading more information and getting more details. So that's it. So thank you for attending. These are the books that I also showed before. Recording will be at NYOUG and OraPub. And again, a plug for training days at UTOG, which is next Monday. I'll be there. A lot of the viscosity folks will be there. And it'll be great. And and then the day after, we're having a bike day. So usually the conference is in March and we have a ski day after for speakers and attendees. And this time we're having a bike day because there's no snow yet in Utah. So if you're in the Utah area, be sure to stop by. And let's see if there's any more questions. Otherwise, I think there's one. Have a good time. Yeah, that's not a question. I will have a good time. All right, I'll wait a couple seconds for more questions to come in. I don't see too many. It looks like pretty much everybody's still there though. So again, thank you for attending. And Monica, I guess I'll pass it back to you.
Thank you so much, Peter. It's a great session as always. We've had Peter speak for us a couple times and it's always great. So I hope you guys got a lot out of that. If you need to contact Peter, just let us know. You can either let Coleman or myself know. You'll see emails from us as well following this webinar. So again, you can find the session slides and a recording of today's session at nyoug.org or www.orapub.com. So definitely look for an email from NYOUG or Viscosity. And we hope to see you again soon. Peter, I'll see you in Salt Lake City on Monday. So till then, bye. Take care. I hope you guys have a great week.
Thank you, Peter. Thank you, Monica.
Okay, Coleman, take care.
Take care.